Please like, share, and subscribe.
And the second is a logarithmic function. That's the inverse of an exponential function. So from this information, the crucial points are your intercepts and asymptotes, since we have a logarithmic function. Now the point of intersection doesn't really matter because it was not emphasized, meaning the point where these graphs touch. How do you spell that now? Section. Yeah. So you can just, you could just put an arbitrary value for that one. Doesn't really matter. So of course, starting off with the linear function, you just let x be 0 to find the y-intercept, and you just substitute. Alright, and again, you let f of x be 0 to now get the x-intercept. So x is 3, so it means we have x-intercept 3 and 0, and y-intercept 0 and 3. Now moving on to the logarithmic function, you do the same. G of 0 log base 2 into 0, that's going to be non-existing. That means we don't have an x-intercept, but rather our x-intercept happens to be our asymptote, since this is the point where the function has no values, and no values simply mean that it does not touch. So that's our asymptote. Now we let g of x be 0 and see what that gives us. 0 equals log base 2 into x, laws of exponents. Anything to the power 0 is 1. So that means our x-intercept is 1 and 0. Now all this information can be drawn right here. That's our y-axis and our x-axis. So of course, positive 1 will be somewhere there, alongside the 3 that we will need. Positive y value 3 should be somewhere there, and positive y value 1. So I'll use the red to represent the logarithmic. Actually, let's use blue. So we know that the asymptote will be somewhere here. That's to say that y is equal to 0. Since there's nothing there. So you could kind of highlight that. But then of course the function will move something like that. It has x-intercept 1 there. Should go that way. Now we'll use black to represent our linear function, which is at 3 and 3 right there, something like that. And that's how your functions drawn will look. The inverse of g, now as you know, g is a logarithmic function, so you'd expect the inverse to be exponential. And all you need to do is just write out the function in the form of y instead of g, so that looks something like log base 2 into x. Then what you do is you swap the two, so x becomes y and vice versa. And what you do is you make y is subject to the formula. Now the way to do that is to use a basic law that I learned some time ago. If I have value a equals b by x, the way to find x there will be to have my base. So I'll have to say x equals log of b into a. So this is like the basic structure that I'll be using to convert this thing here to make y is subject to the formula. So I'm going to have 2 there as my base, and then the x on the other side as my exponent. And that is my subject to the formula y. And this is literally the inverse. So we are asked to the answer in this form. But we know that in actual essence, this is the inverse of g, which is just 2 power x. The question is how? How would you solve this? Well, very easy. You know that this is the, that's like your logarithmic function. So basically, what you will do is simply reflect the function. You reflect g of x. G of x must be reflected about the line y equal x, also known as the mirroring line. So that's the line that passes through the origin that happens to indicate the inverse of any function. So the solution will be to reflect the graph of g to obtain the inverse. So you reflect it about the origin. See that? So that where so that you actually get to the point of intersection. So initially we had something like this, right? So this is the line I'm referring to, the line that will allow us to kind of mirror this particular function here to look something like this. That point there will be the reason behind this function or equation, the point of intersection. So the way to solve this will be to reflect g of x about the line y equals x, which is that red dotted one there. Get to the point of intersection. That will enable you to equate the two functions. The way to solve this equation here would mean that this is the point of intersection. So we have a point of intersection between the reflected function g of x, which is none other than the inverse actually, and the function f of x, which is actually minus x plus 3, which can be rearranged as 3 minus x. And then we have the inverse, which is 2 to the power x. So if I equate the two functions, what I will get is something like that. So this part is 3 minus x, and on the left hand side we have 2 to the power of x. Again, using the law, a equals b power x, where x will be equal to log base b into a. I can work this out. See, the exponent there is my solution. Or rather, let me just say x equals log base 2 into 3 minus x. So this example enables us to actually attribute the fact that since our initial x, rather let me say our initial x-intercept which was at 1 and 0 will now be our y-intercept. This is now for the inverse, right? So in other words, I'm going to use this initial x-intercept of my logarithmic function. I'm going to use that x equals to 1 to check to see if I'll have the same answer for both sides, left hand side and right hand side. I have my left hand side being x, and my x is 1. My right hand side has to be equal for me to prove that this is the solution. So let's go ahead and check what we get. This will of course be log base 2 into 2, which is the equivalent of 1, but you can test it out in your calculator for yourself and see what you get. So now that the left hand side is equal to the right hand side, which is equal to 1, it means that indeed our solution is x is equal to 1. So in other words, the solution to the intersection of the inverse and the straight line function is x is equals to 1.